Well, good morning, everyone, and let me first extend a warm virtual welcome to all of you to Victoria, British Columbia, Canada, where I'm recording this presentation in the morning of what looks to be a nice late winter day. Clear skies, sunny, 10 degrees Celsius by midday, and no rain or snow in the forecast. For those of you who are skiers, though, plenty of snow on the mountains within about 100 kilometers of here, and plenty of hills to challenge every level of ability. I'm Frank Driscoll. I'm president of FBD Associates. I'd like to spend some time this morning giving you some insight into the tools and techniques that we use to cost effectively migrate natural ADABAS applications to functionally equivalent Java DB2 applications executing on zOS, whether on-premise or in the cloud. For those of you not too familiar with natural ADABAS, these are products that came to the fore in the late 60s, early 70s. They're products of a company in Germany called Software AG. At one time, they were quite popular. At one time, Software AG had a 12 to 14% market share of mainframe databases in competition with IBM, IDMS, and so on. But more recently, as technology has progressed, the number of sites worldwide has declined from what used to be about 5,000 in their heyday, early 90s, to, by some estimates, closer to 2,000 these days. Okay. As to why people are migrating off of ADABAS and natural, there's all the usual factors at play. In its heyday, ADABAS was a very fast, efficient, inverted list database, and was had significant competitive advantages in the days when CPU and memory were in short supply. Nowadays, those issues don't pertain so much, and there are also associated issues with license costs, the demographics of the human resource base, various other factors that come into play. So we've seen a fairly steady flow of customers looking for support and solutions to accomplishing these migrations, just because they want to get to more modern technologies, they want to get to the cloud. So with that, we'll get on with our agenda and give you some insight as to how we do this. And just give me a minute here to share screen, and we'll get started, okay? So first of all, in terms of the agenda, we'll obviously give you a little bit of background on us, our corporate profile, spend quite a bit more time on our solutions and the tools portfolio, the various architectures and capabilities of each of the components of our solution space. Also talk about some implementation and sequencing issues, particularly for complex portfolios, with a few comments on obviously the cloud, given today's marketplace, and then lastly, a case study for a significant university here in Canada that we implemented over the last couple of years. First of all, in terms of our own corporate profile, I actually started in the early 90s, getting involved with this with respect to converting natural 1.2 and natural 1.4 to natural 2. Software AG didn't provide much in the way of tooling for that kind of migration. And we actually did quite a number of projects for Software AG itself, particularly in the VAX, if you remember that, VMS space, okay, taking them over to Unix. We also, of course, as everybody else in the business did a fair bit of work on Y2K analysis and remediation. And the overall technology development, the tool development, really spans the era from the early 90s to the present time. We've invested a fair bit of R&D to basically improve the productivity of the tooling and drive out the hand labor content of any of these migrations. And we've also accumulated a fair bit of exposure to large volumes of source code. We've done over 200 customers in various activities from the early migrations through Y2K to the current activities, and dealt with one customer who actually had 325,000 modules and 25 million lines of code. So scale is not a problem in terms of our capacity. Our capabilities essentially these days are focused on natural ADABAS, natural VSAM, natural DB2 applications, basically all the same flavor, different database, and so there's different database manipulation tools, but the natural is very much the same. And we frequently see in those efforts COBOL database applications. So we're currently finishing off modifications to our tooling to deal with the replacement of the database calls in the COBOL source code, not converting the COBOL to Java, but just having it run against a DB2 database on zOS. And natural database to Java DB2 on zOS is actually our most common solution. We have done other things, but that's the big enchilada, so to speak. We primarily are a technology provider. We do provide some services, and we do work with SIs depending on the circumstances. In terms of the portfolio of tools, really breaks down this way. Obviously, the first thing one has to do in any of these circumstances is to do a fair bit of analysis. And so we have some tooling that provides that, call it NapMiner. And the first order of business in any of the migrations is actually dealing with breaking down the application into units of work, I should say, okay, basically, because as an example, with our recent case study, 2.5 million lines of code, you cannot swallow that at all at one time. And so we break it down into, in this case, it was broken down into about 12 or 13 units of work, okay? As well as that, and before you can actually deal with migrating the natural code, of course, you have to settle on the database design. And so we have tools for doing that, which will generate a normalized equivalent schema in DB2 from any database file, FTT, file definition table. We have tooling for extracting and converting database data to DB2 load files, and we do that in one of two ways. So it depends on the circumstances. We actually have a tool that can map an database data on load over to a DB2 file, which is useful if you're going to DB2 LUW as an example on Z-Linux, or alternatively, we generate natural programs in the associated JCL to generate DB2 load files from an data on load, okay? Sorry, not from data on load, from the database itself. The tooling for actually converting the natural to Java is our JavaNet tool. Most important element in this description here is that statement to statement highlighted in red. Very important technique in terms of preserving the structure and business rules of the application, preserving the look and feel, the architecture of the application when it gets over to Java, so that that Java can be easily maintained by your existing natural database support people. That's been our experience with multiple customers. Finally, we have some advanced R&D going on in an area where a lot of people are interested, but there's really no silver bullet at this point in time in terms of automated recovery or reformatting of business rules. That's state of the art, and there's no magic. These tools are intended to provide leverage, if you will, to human beings, smart human beings doing the actual discovery. In terms of an architecture of the tool sets, they virtually all rely on or integrate in this sort of fashion, starting with natural source and database data on loads. On the left-hand side, progressing through various parsing, loading, decomposition steps to populate a relational database repository from which transformational applications are applied to generate various reports for analysis and management, to do some database modeling, to support data migration, and to support the generation of the Java source code, the data files for the DB2. And one thing mentioned there, we do have a capability to generate EGL as well, which of course is an IBM technology, very Java-like, but it's essentially, well, it lost the war to Java, say, basically. And so there hasn't been a lot of demand for that sort of thing, but we do have it as a capability. First of all, in terms of NapMiner and doing migration assessments, you'd have what you would expect. Lots of metrics, audit reports. One of the most important things that's dealt with is the question of the integrity and audit of the source code to confirm missing modules, and if something is missing, We need to interact with the customer to determine why it's missing, whether it's legitimate, whether it can be provided by some other means, and so on. Okay, so we don't want to start processing on the downstream until all of these sorts of things have been resolved. And if, in fact, you do want to do some redevelopment of an application, then this tooling can provide certain reports and information that will be useful for those sorts of things, okay? Particularly the normalization of database file definitions to a relational schema, very helpful in terms of trying to understand what actually these database mechanisms are, okay? Just a sample of one of the reports showing you what we've produced. Notice down the left-hand side, a long list of reports, 40 in total generally, and more as time progresses. In this case, we're looking at a file definition and giving you some of the details with respect to it, as well as a graphic illustrating the structure of it, which people find very helpful in terms of trying to understand, you know, databases that were designed perhaps back in the 80s, okay, and the designers of which have long since retired. Once you're beyond graphics and that sort of thing, you also want to find a lot of details about the relationships of various things. In this case, this is one of the reports, the work file usage, and you'll notice that some of them are highlighted, and you can actually, they're all hyperlinked. So as an example, if you want to find the line number where a particular work file is referenced, okay, you can do that, and then you can click on that link as an example, the 33 in this case here. If you clicked on that, you would actually jump out to a report that shows you the HTML marked up source code where that occurs, and you'll find the details of that particular usage of that work file. For database transformation and data migration, it's not as though you have a blank sheet of paper where you can sketch out the ideal DB2 schema to your heart's content. It's actually a specified engineered design criteria that we apply using these rules. ISN as a key as an example, descriptors mapped over to indexes, MUs and PEs, mapped to child and grandchild tables, supers and subs, and so on. So we have a set of rules, and there's a fair bit of flexibility in terms of some items, such as you know, table names, excuse me, table names, data definitions, that sort of thing, and to obtain customer input on that, those variables, we have a web application which presents the conversion of the database FTT to relational and the various things that you can input, and we capture that information from customer input, or they tell us, and we use our defaults, various strategies, but nonetheless, fairly straightforward way of getting what the customer wants in terms of any specifics. And then once all of that is done, you click a button and it automatically generates the DDL for the DB2 database. Data migration, as I mentioned earlier, we simply map the DDL and the database data, if it's in an ADA load form, or actually run natural and extract database data and generate DB2 load files. As I mentioned, with this set of rules, there's limitations on what can be done, but from a tuning perspective, first of all, I should say that in general, we have not, notwithstanding the sort of general perception that database was a highly performant database, I should say, we've not really had an issue with tuning other than some selected cases where we were able to modify the natural source code before translation, and in general, we have not had either online or batch performance issues, and I'll talk a little bit more about that when we get to the case study, some of the things we did at Poughkeepsie with IBM. From natural to Java, okay, the tooling generates a 3-tier J2EE application. Again, that emphasis on a statement-to-statement conversion to procedural Java. And we do that, first of all, to maintain the business rules, but also importantly, to make maintainable Java source. We don't want gobbledygook And also with that, you can add features using regular Java development tools. JDBC access is appropriate, and then the Java's IDE and platform independent. So while we specialize in going to zOS, the zOS is running the Java, it runs on a specialty processor, runs on Z-Linux, runs on Red Hat Linux, okay? So you can pick and choose if you like. There's little or no manual editing of the generated source code, less than 0.5%, and in many cases, it's simply a review by a expert eye of some particular transformations that are sometimes difficult to migrate or transform 100% accuracy. So all of these things are flagged, and somebody has to review them, and occasionally some of these have to be edited to adjust, particularly things like re-input. But emphasis on the logic quality and the business rules are unchanged as you go through this process. So simplifying testing, typically unit testing using simple test scripts are appropriate, and experts from the customer are usually the appropriate human resource to conduct that sort of testing. We will do it at times, some of it. We certainly, before we deliver anything to the customer, apply a certain level of what we call quality assurance testing. Typically, we get a subset of the customer's test cases and either test it in our IDE or actually get a VPN connection to the customer's test database. The result, bottom line, functionally equivalent. You can do a lot to upgrade the 3270 in a browser JSP-based UI using AJAX or JSP technologies. Again, logic quality, business rules unchanged. A philosophy of make it work, then make it better is the implementation paradigm that we highly recommend. If you're going to try and reformat, refactor, redevelop along the way, on the fly, so to speak, our view is that that is a high-risk behavior and not one that we would recommend. In terms of UI improvements, some fairly straightforward, simple things can be done. You'll notice the University of Toronto took our UI on the right, which sort of looked like that, and I actually dressed it up with their logos and integrated the menu with other applications that they have, and preserved, among other things, the command line execution option for expert users who have been using the application for years and have a particular style of operation. We preserved all of that, but made it look neater, tidier, and so on. In addition, you can quite straightforwardly add things like date pickers, hot links, and edit masks to fields, okay, with the use of these JSP technologies. Quite straightforward. In terms of implementation responsibilities, when we do these projects, typically it breaks down this way. We tend to provide the SMEs and the tool experts. Our people have, in addition to tool expertise, are actually long-time natural database developers and architects. We probably have 200 to 300 person years of experience amongst our key people supporting and developing natural database applications, natural DB2 applications, okay? But the flavor of the week for them is generating the Java and doing the review and the quality assurance testing. From the client perspective, we'd like to have access to the application SMEs if they're available, and most appropriately, they are heavily involved in unit and acceptance testing. And typically, these projects involve a lot of moving parts, and we'll talk more about that further on. And for those kinds of projects, we engage with IBM, who can provide system SMEs, particularly in the area of system integration and project management. So that's how we see the responsibilities breaking down. In terms of how you go about this sequentially, it's more or less a pretty straightforward activity. Obviously, some pre-sales, convincing the customer it's the right strategy. PDRM is what we call our project definition and risk mitigation effort. And during that process, we take samples of first of all, we take all of the natural source code and database file definitions and parse them up and populate the repository, as I showed in the earlier slide. But we also take samples, critical samples of some of the programs, some of the database files, and actually migrate them, convert them to Java, convert the database data to DB2 data, create a DB2 database, and actually run some quality assurance tests on that unit of work to, first of all, work out any bugs that might appear, but more importantly, to exercise all of the human talents that are required to move these things forward. Once that's done and the customer has committed to going forward, we do a more substantial baseline migration, typically on the order of several 100,000 lines of code, similar reasons, and do the same sorts of functions, and then rinse and repeat through the rest of the source code until you've got it all deployed and in production. Whether or not you go to a big bang for the entire database, or you do incrementally transitions, depends on what we call an affinity analysis of the database source code, the database file definitions and the natural applications, and you try and isolate an application against a certain set of files that can be moved independently. If that's not the case, and it's often one way or the other, there's no real way to predict which one is going to turn out, absent doing all of the affinity analysis. But in general, it is quite practical also to do a big bang, and that's what our case study will show. They simply practiced it sufficiently and went to production over the weekend, come in on Monday morning, set to work, and didn't look back. And then, of course, once it's all done, you can start the issue, as many people want to do, of re-architecting and adding new functions, which in our case study case, was actually well underway as we spoke to them last week. Getting started, no question in our minds that this project definition PDRM activity is critical to a successful project. And in detail, as I mentioned, we analyze, we prototype, we work all the issues in any of the migration from front to back, and establish that everything has been looked at, and the only question from that point forward is getting the volume of the source code done. In many cases, I'd like to talk briefly about the question of complexity, because this is a challenge we're seeing more and more in the customers. This actually is real data from a customer that we're currently proposing to. Their stated objective is to get to the cloud and to go through an outsourcing arrangement with IBM initially, but they want to be cloud operable by the end of this process, and to go forward on the hybrid cloud. So when you look at that and you say, okay, where are we at the moment, and what do you have to analyze? Okay, we do what we call a phase 0, and you can see that there's various technological components, I might call them. Natural itself, database, data sets, the typical in blue IBM technologies, and the software G technologies highlighted there in yellow. The reason I have red on the bottom there is, in fact, typically customers don't come to us unless they have these challenges. The cost, the technology, and the support are driving them to look at what are my options for going forward and lowering my costs, getting to more advanced technology, getting flexible support arrangements, getting flexible pricing arrangements. So in step 1, we typically, for this particular customer and others, we would recommend concentrating, first of all, on retiring the natural database components. And you can see there that the strategy is to move natural to Java because it plays in the long term. Database to DB2 and data sets to DB2 as well. DB2 zOS in the first instance, and then potentially DB2 LUW on the hybrid cloud, or it could just as easily be DB2 zOS as well, since both of those are available on the hybrid cloud. Notice that in phase 1, there's a lot of blue that doesn't change, okay? And of course, that lowers your risk, lowers your costs. As I say, the important factor here is to convert the natural database to Java, the database to DB2, to displace various utilities provided by software G, and to deal with some of the other software G products that are typically installed in these environments. Okay, so our conclusion is that doing phase one, you probably get maximum ROI for dollar invested, but it's not the end of the story, of course, because a lot of customers, and this customer in particular, got their Z14 about a year and a half ago, are looking forward to the normal 5-year duration of an outsourcing contract, which is already in place, and looking to retire at that point and get out of the data center business, really. Okay, and so in that context, they have choices which were currently being reviewed with them, and of course they can go in some cases to DB2 LUW, but they may stay on zOS or Red Hat on Z or P or Intel. Right? It's all there on the hybrid cloud. The major component of the work vis-a-vis the natural applications at this point is to convert the JCL, because I didn't quite mention it, but a very significant advantage of deploying the Java DB2 on zOS at step one is that IBM provides a utility called JZOS, and what that allows is it allows a Java application running on zOS, especially a processor, to access all of the zOS environment and the utilities, okay? And then in particular, the JCL to run what used to be a batch natural job, converted now to a batch Java job. No modifications to the JCL are required to do that, okay? One small proc has to be provided, but essentially all of the batch can run in the first phase one, can run with unmodified JCL. And that, of course, reduces the scope and effort, as I say, cost of doing the migration. When you go to Red Hat and Linux, of course, you do have to do something about the JCL, and you do have to do something about the JCL utilities. So we have various solutions to those items. Notice that the IBM Blue technologies continue on through, as I say, whether it's DB2, zOS, or Power or Intel. In this case, they had some COBOL vSAM applications, which in phase one, of course, could just simply run on zOS. But in phase two, where you're going to the cloud, you have a choice. It could be continue to run on a Z machine in the cloud as part of the hybrid cloud, but it could be converted to Red Hat Linux. And so we have actually proposed that this issue be looked at more carefully during the PDRM to establish, what is the true TCO analysis-based decision-making for this activity. They also have an ISV report writer accessing vSAM, and that's colored in red because that's definitely a TBD, whether it goes to the Z cloud and stays and continues to run, or convert it to Java and have it run on Red Hat. The small problem is that that ISV is no longer with us. And so there is no industrial support for that report writer. It's a custom piece of work that was done on behalf of this customer, and which they use fairly extensively, about 400,000 lines of that code, all peculiar and unique to this particular customer. And there is apparently no other user of that report writer. So challenges in terms of finding a solution other than having it continue to run on zOS, which of course you can do. And so the net of all of that for phase two is that you, as a note here in the bottom, you've got incremental, what I would call incremental ROI per dollar invested, okay? Because you're getting, as any buddy who's got some familiarity with Sod's laws, okay, you get the law of diminishing returns in terms of return on investment, okay? So that's one way of looking at something that's technologically complex, and it's important in our view to do this, okay, to sort of sort out your thinking with respect to how to go about this particular migration, which, as I say, is more likely to be the case that we're seeing going forward as more and more of our customers have complex portfolios that they can't quite figure out what to do with for good reasons. In terms of a sort of timeline roadmap, we did work this view of life for them, okay, and are currently in discussion with this particular customer. And this is a 10-year roadmap, okay, showing First of all, as I note here, fairly substantial portfolio, like millions of lines of source code, multiple applications, various replacement strategies that they'd like to implement. In this case, just looking at the first one where it says admin, these are custom applications, natural database developed over the last 30 years. And some of them they would like to abandon, but others they definitely want to keep. So in this case, it used to be 4.5 million lines of code. And essentially our first analysis suggested that a million lines of code could be abandoned, but 3.5 million would be converted to Java and DB2 running on zOS, 2.5-year timeline. Part of the timeline is a requirement to moderate the demand on their SMEs. They've got a lot on their plate, so they don't really want to devote 100% of their time to doing this migration. So we're in effect taking it somewhat of a moderate pace. And then, so phase one is, as I mentioned, take this natural database to Java DB2 on zOS. Step two is either stay on zOS if it's a hybrid cloud, or migrate to Red Hat Linux, okay? The next application is one where they want to do a COTS replacement, okay? You notice that it says financial. And the particular functionality can be bought in, okay? There's technology out there to do what they do now. And the real challenge is how do you make sure that the new technology, like an SAP application as an example, often has to be customized for a particular customer's business processes. Similar thing in this arena in terms of the financial application. So they're trying to sort all that out, and there is an estimate that they could get that done in the same time frame, which in terms of getting to their ultimate objective gives them some schedule slack. But as you know, slack is often consumed fairly quickly. And so they need a backup strategy, which is illustrated there, which is the contingency plan, is that if in fact the COTS implementation slips, then at some point they would decide to convert what is a combined COBOL database and natural database application to run on the cloud in some form or another, okay? So that's TBD, and that's going to be one of the things we were doing in the analysis, is to put more definition into the level of effort and timing of this. What you're seeing here is essentially a conceptual model of how this would be done. There are some other applications in various technologies. COBOL vSAN, as I mentioned back, it's often the case, and a custom report writer and so on. And then there are a bunch of non-database related ISV applications, 60 in total, that have to be sorted out. And so in the near term, the intent is that stuff simply being maintained on the Z14, and then develop an individual strategy for those to determine whether they get put over onto the hybrid cloud on a Z machine, or whether they actually get converted. Hopefully by the end of the 5-year period where they would like to retire the Z14 and get to the cloud, then you would be ready with this scenario to proceed with hybrid cloud production operations and have retired natural database for sure, and possibly the Z14, almost certainly the Z14, and some of these other ISV applications, okay? So as I say, these complex projects, you need to look at them from several perspectives. They can be quite challenging, and it's important to get your strategy straight and to get realistic estimates for cost, time, level of effort that you're going to need to support these migrations, particularly the use of what is often the case are limited SME resources inside customer organizations. Vis-a-vis cloud, I'll just note that Gartner's Magic Quadrant 2020, so fairly current, and I don't think this would surprise anybody. Amazon is, of course, up there in the lead, and IBM is somewhat behind. But Ginny seems to have come to grips with exactly what needs to be done, and perhaps a good perspective. And of course, that's currently being reflected in the management changes at IBM, as well as the intent to restructure and spin off the hardware infrastructure business and concentrate on cloud. It is true, at least from our perspective, in terms of what we're seeing, the simple jobs have been done. And as I showed you, illustrated in the previous slides, what we're seeing more and more are fairly complex and challenging migration issues that require a good, solid technology solution, technology and timing and scheduling solution to be cost effective and to produce the ROI that people are expecting. In our view, these hybrid cloud architectures definitely can provide leverage to IBM and customers to catch up. The hybrid cloud, from our point of view, it offers a single vendor, secure, reliable, all of those parameters with multiple OS solutions, complex portfolio, progressive modernization. Okay, so key words: complex, complete portfolio of your applications, just not narrowly focused on natural database itself, and a progressive modernization over time, because a lot of organizations simply can't swallow the degree of change that would be required to do this on a short-term basis. And then there's no question, I think it's often said that people are looking for mainframe modernization, and then I never quite understand that, because the mainframe itself is certainly a modern platform. DB2 is a modern database, and what's not modern are some of the applications and some of the technologies that have been in use in other areas where they're out of the mainstream of the technological solutions and challenges facing us today. We think that JAVNet has a role to play, particularly since it produces cloud-native, compatible, readily integrated applications, and these can be, as the University of Toronto has shown, can be integrated with their other Java applications. So they're quite thrilled with the results that we gave them. It also provides a standardized approach to application development, DevOps, and so on in the cloud, which of course is the future, really. And last but not least, of course, is ROI, always an issue. You got to produce the bottom line results, and you got to get skilled technical resources reallocated to boost your competitive advantage to cost saving and functional enhancements. So case study, quick overview of this. University of Toronto, in Toronto, of course, and largest university in Canada, faced the challenges of registering close to 100,000 students. Used to take a number of weeks in late summer and early in the year on the two registration cycles, obviously. They had acquired a natural DB2 application with some database components that was acquired actually from another university in Canada. A fairly substantial application, 2.8 million lines of code. You can see the numbers there, 4,000 screens, 8,000 modules. They looked both at the application, its functionality, and their own internal resources, and recognized that, among other things, they weren't keeping up with what they wanted to do, couldn't provide the functional capabilities fast enough to their customers inside the university. And the demographics of their employees were disturbingly long in the tooth, and they had to be concerned about retirement and loss of key expertise, particularly given that they weren't the original designers of the application, and so they didn't have that connection. They were also executing on the BC12, and the consequence of that and the horsepower on the class of the machine was that they effectively were rationing windows of registration to students and requiring them, because they simply could not cope with the volume if everybody tried to log on at once. And also, this application wasn't just a light to do some nice administrative task. It was doing all of the student registration activities, course assignments, scheduling, and most importantly, generating close to $1 billion in fees. Okay, so after having spent some money, cooperating on a what was to be an open source development project for a number of universities in the US. They did the right thing, in which they actually did some analysis after getting closer to the design specs for what turned out to be the Koali project. And they realized that customizing that application to meet their own requirements would require substantial rewrite activity and wouldn't really easily provide some of the functionality that they had put into the application that they acquired from another university. And so they talked to us, we gave them a proposal, and in the end, they spent with us about a little under $3 million, and they reckon that they've achieved a cost savings within 24 months. We took originally scheduled 18 months to do the job. We had two major disturbances in the force field during that period. One driven by the Ontario government, which changed all the registration arrangements for universities in Ontario, made significant demands on the university to modify the application. So we had to take a time out, and while they modified the natural application to satisfy those requirements, about 4 or 6 months. And then on top of that, in the end, they decided that they really would rather go to Red Hat Linux, okay, rather than zOS itself. So in the end, it took about 3 years, and it went. We finished our work in November of 2017, and they did their testing and user acceptance and planning and preparation. They only have 2 windows where they can actually install a major change. Obviously, they want to stay away from peak registration periods. So those windows are in the March timeframe and in November. They couldn't make March 18, but they did make November of 2018, and it's been running flawlessly in production since that time. They consolidated all their skill sets to Java, which was part of the driving force to get to Red Hat Linux. And they also eliminated the natural license costs. And most importantly, they were able to get substantially improved performance so that during the peak registration periods, they were never running at more than 35% CPU capacity on their server. They, of course, maintained all of their unique business rules. And curious thing, well, you think of University of Toronto as a big institution, it's actually a collection, a federation, if you will, of 7 different colleges with 7 different IT systems supported by a central IT operation for common systems. And keeping all that under control is quite a challenge. So they nonetheless and had developed lots of unique business rules that they preserved by converting the application. The 3270 in a browser interface essentially required a trivial amount of user training for people to come in. As I say, they went to production over the weekend in November of 2018, came back up on Monday, and didn't look back. They had obviously practiced quite substantially. They had run over 1,800 test cases and had about an 800-step checklist for that process over the weekend, and had a great staff supporting them to get it done. So all the details are available in a case study, but this is one of our major accomplishments over the last few years. And with that, we'll open it up for questions, and just remind you to fill out the session evaluation, and happy to take your thoughts and comments, feedback, questions, whatever you like.